To start this next video, I want to go ahead and just bring back again the implication. So this is an if-then. If A, then B. Right? That's what this is saying. And this is sometimes called an implication. The idea here is that we want to be able to manipulate A and B and what this sentence is saying and try to see if we can't rearrange it and gain something that is still true. So let's go ahead and see what would it be if we were to call this if B then A. So let's come up with some tests that can determine is this true or not. So let's say A is let's say Anne is swimming and B is Bob is swimming. Now, so here's what this is saying. If Anne is swimming, then Bob is swimming. So in order for this to be true, either Anne is swimming must be true, with Bob swimming being true as well, or you just need it to be false, that Anne is swimming, so Anne is not swimming. So let's consider what this says. Bob is swimming. If Bob is swimming, then Anne is swimming. So Bob is swimming must be true and Anne is swimming must be true, or Bob is swimming just must be false altogether. In order to set these up and to determine are they equal, we're going to go ahead and make our truth tables. So whatever A and B happen to be, and then B implies A implies B. So when A is true and B is true, both of these happen to be true. When A is true and B is false, in this scenario, since I have a false implying a true, this is true. But since this happens to be a true implying a false, it is false. So it breaks down. It does still break down. And because of that, we know that A implying B is not the same as B implying A. Using our same example of Anne is swimming and Bob is swimming, so if Anne is swimming, then Bob is swimming. If we now compare it to Anne's not swimming, if Anne's not swimming, then Bob is not swimming, we'll see what we get. So again, setting up our truth tables, we want to see if maybe this would be a similar or logically equivalent statement. So our possibilities for A and B are both true, one true, the other false, and then false, true, false, false. All we need is one contradiction to show that these are not the same. They're not equivalent. So if they're both true, 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 this is true, and we can fill out the rest of this table. We know that this would be false, and these would both be true. Not A, so that would be a false implying something. So as long as A in both cases is both true, this is going to be, this part of the implication, not A, is going to be false, so it makes the whole thing true both times. So it gives you a true and a true. When A is false but B happens to be true, which would make this a true implying a false, it becomes false. So again, in this case, it doesn't quite match up in the middle to truth values. Now what we're going to compare, so A implies B, what we're going to do is we're going to swap them. So I want to compare it with B implies A, but now I'm going to also negate both of them. And we'll see what happens here. So I've got a not B implies not A, and the regular A implies B. So true, 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 false, false, true. Okay, so here true implies true. Well, that's true. True implies false. This is our only contradiction. And then true, true. Let's look at this scenario. So not B. When B is true, not B is false. So this is automatically going to be true. So any situation where B is true, these come out to being true. Now when B is false, this becomes a true implying something. So when A is true, this becomes not A being not true, so false. True implies false, which is a false here. Lastly, when A is false, this is a true implies true, so this is true. So it matches. So these are actually logically equivalent. To say A implies B is equal or equivalent, this is logically equivalent to saying not B implies not A. So we'll go ahead and name these. This one, which is logically equivalent, is known as the contrapositive. So every single time you have the contrapositive, all you're doing is you're just negating both statements, both propositions, and switching the order of the implication. And the contrapositive is always logically equivalent to the original implication. This particular example that we had, which was not logically equivalent, this is where we negated both A and B. This is the inverse. The inverse is not necessarily true, right? It might happen to be true in some cases where they're both saying the same thing, but there's still possible cases where they are not equivalent. Lastly, this here where you just change the order, so instead of having if A then B, I say if B then A, this is the converse. And I hadn't written out the rest of these. A implying B was true and true there. Here, B implying A is false and then true. So again, these are not logically equivalent. But you might notice something here about the inverse and the converse. The inverse says true, true, false, true in its truth tables. And the converse says true, true, false, true. So in both cases, the inverse and the converse happen to be logically equivalent to each other. And that should make sense. Because if I consider A implies B, the inverse is not A, implies not B. The converse is B implies A. The contrapositive was not B implies not A. If I take the converse and I take its contrapositive, I just negate the second one, so B to A. So I negate the second one, not A, and then I say implies, and I negate the first one, not B. So the converse and inverse are contrapositives of each other. So that's how the converse and inverse and contrapositive work. The converse and inverse are not necessarily true, so you have to be careful. You don't want to take a statement and make a converse error. That would be like saying, if it rains, then I will use my umbrella. To say the converse would be to say, if I use my umbrella, then it rains, which may or may not be true, depending on this first sentence. This first implication, if it's given that this is true, you can't necessarily conclude the inverse or the converse.